Today we will solve problem 1 from IMO 2024. Determine all the real numbers alpha such that for every positive integer n, floor of alpha plus floor of 2 alpha up to floor of n times alpha is a multiple of n. Note that floor of z denotes the greatest integer less than or equal to z. For example, floor of pi equals -4, and floor of 2 equals floor of 2.9 equals 2. Problem 1 is usually the easiest question among 6 questions. 65% of the candidates scored full points from question 1. Let's solve this problem. This is an algebra question. We have to find the possible values of real number alpha that satisfy a condition. The given expression is divisible by every positive integer, n. The floor function is a little bit tricky to handle, so we will consider alpha as an integer first. When alpha is an integer, we can remove the floor function as it rounds the decimal part. This can be written as the sum of alpha, 2 alpha, up to n alpha. Factorize alpha to get alpha times the sum of integers from 1 to n. The triangular sum in the bracket is the same as n times n plus 1 over 2. If alpha is even, let's say 2m, the expression becomes m n times n plus 1. Since both m and n are integers, this expression is always divisible by n. So if alpha is even, the expression is always a multiple of n. If alpha is an odd integer, we can check manually. When n equals 2, alpha plus 2 alpha is 3 alpha. Since 3 and alpha are both odd integers, it is not divisible by 2, which does not satisfy the condition. Draw the number line to help check other real numbers. Even integers satisfy the condition, but odd numbers don't. Now we will check for the real numbers. All real numbers can be written as even integer plus decimal part, or even integer minus decimal part. In this expression, 2m is even integer, and d is the decimal part between 0 and 1. In the given expression, each term can be written as the integer part plus floor of the decimal part. This doesn't change the value as the floor function rounds down the decimal part. We will evaluate for 2m plus d first, so we can regroup the expression like this. The sum of even integers is mn times n plus 1, and we already proved that it is divisible by n. So we have to evaluate the floor function part. D is less than 1, and it is rounded down to 0. As the value of n increases, at some point, the value of d times an integer, let's say p, is greater than 1. So the floor of d times p becomes 1. When n equals p, the expression equals mn times n plus 1 plus 1. This is not divisible by n. We can use the similar reasoning for 2m minus d. The expression can be written as mn times n plus 1 plus the sum of the floor function. Since negative d is between -1 and 0, it is rounded to -1. As the value of n increases, at some point, the value of negative d times an integer, let's say q, is less than -1. Then the floor of negative d times q is -2. When n equals q, the expression becomes mn times n plus 1 minus n minus 1. Minus n minus 1 is not divisible by n, where n equals q. So we can conclude that all even integers satisfy the condition of the problem, and no other real number alpha does so.